Trigonometry. Hello and welcome to
Miles Thompson
and Brian Clifton
present
Fun with Maths.
What are we doing today, Miles?
Fractions and decimals.
I actually really like fractions. Fractions are great. Don't you agree?
Yes.
Let's get started with some fraction fun.
Yes.
So, what specifically about fractions are we going to be covering today?
Recurring decimals and how we can convert them into fractions.
Cool. Okay, so shall we get started with some things?
So, what is a recurring decimal, Bryony? Let's see if the audience can figure us out. What do you think recurring decimals are, Bryony?
Well, I think I can explain it to you.
Go ahead.
So, if something's recurring, it means it happens again and again, really. Only in mathematics, it means it goes on for infinity, right?
Yes.
Yes. So, the first one doesn't have to be a zero, but it can be a zero, and we're making it a zero. Why not?
Oh, can I pick the next number?
Yes, you can.
I like 7.
I like 7 too. It's not one of my favourite numbers, but I like it.
My favourite number is 12,407. It's uninteresting.
I like it too. What number next?
6.
The other numbers, or should we do like that? And then we'll do dot there and dot there. And that means that this sequence of 7, 6 goes on infinity. So
I will write that down in red to differentiate itself from the others. 0.7.
So that is what
7.
a recurring decimal is. Just a decimal which has recurring numbers, and it can have many, many different digits recurring in a different sequence. Or it can just have one. You can stop now. So, this as a fraction is
76 over 99.
76/99.
Yes, that also works.
And now we shall explain something interesting to you. If I were to have, say, 0.5 recurring, I can write this as 5 over 9.
Whoa, why?
Miles, feel free to explain.
Well, it is because when you have a unit over a number, it means it is recurring.
The number specifically has to be 9 that it's over.
Yes.
Yeah.
An example of one that you may commonly use is a third. 1 over 3.
This can also be written as 3 over 9.
Or even 0.3. Do you understand now? Can you guess how we can simplify that decimal further? Great! How did you work it out? Was it because we technically have the answer up here? Brian, would you like to write down a simplified version of that?
I see, okay.
Darn shooting, that is sure satisfying.
sure is. It allows us to work out any kind of recurring decimal that we have. So any recurring decimal that we have, we can calculate this as a fraction. So if you have a 0 before your recurring decimals, before your recurring digits, what that means is that all you do is you just add a 0 onto the end. So for example, if you were to have 0, so 0.02 recurring, so instead of having, because the recurring sign is here, what that means is this 0 does not recur. This 0 is just here, but all the 2's recur from infinity, and the 0 just sits here. So Mars, you can write out what percentage we're doing now.
Yay! 0.02222222222.
Why are the 2's so small? They look like subscript.
Small 2's because they are signals. They've hatched from the X.
The 2's have from the X.
That's how I remember it.
So writing this as a fraction, if we have 0.2 recurring, remember that is 2 over 9. But if we have this, we write that instead as 2 over 90. 2 over 90. And all that does is just say we have a 0 right there. And when we have even longer decimals, it all still works the same. And we can explain to you now why that is.
We shall resume with our example. So if you were to write this out as what we need to do is get rid of this recurring section so we can put this into a simple, easy fraction. So to move this, we just need to times this by 10. And now, an easy way to get rid of this is just to subtract 1m from 10m. So 9m, 9m equals 2, and we can simply move this around to get m equals 2 over 9. And we can do this with far more complex examples. So a pretty easy fraction, I suppose, once it's simplified, but when it's written out, it's, so this is our decimal. 0.0714285 recurring. Again, our 0 isn't recurring, it's just this sequence of these 6 numbers. So, really, to get this, so that all of this is in front of the decimal, we need to times this by 10 million. So, 1 to the 7m equals equals 714,285 point, and then that will recurring again. And so if we simply subtract 10, because what we have to do is remove this one space
explain to you what happens when the number isn't as simple with just a 0. This doesn't get complicated, do not worry. If the number is something like 3.1 recurring, so what you do is you do the same thing as before. You go to 1 over 9. However, what happens to the 3? Well, what happens is, let's see if you can figure it out. What happens is it simply moves in front of it. So 3 and 1/9.
Who would have thought?
I don't know. What other fraction is this equivalent to? Right.
So this is also the same as 28 over 9. It depends on your preference as to how you would wish to write it.
This is top heavy.
And this is a mixed number. We've been your hosts this evening on Miles Thompson
And Brian Clifton,
present
fun with maths.
because maths is very fun.
Yay!